Hey there, science fans! Welcome to an exciting journey where we explore the hidden forces that make our world tick. Have you ever thought about the invisible forces that shape our world? These forces are all around us, influencing everything we do, yet we rarely stop to consider their impact. You can't see them, but they're everywhere, powering everything from your phone to the lights in your home. Imagine a world without these forces. No smartphones, no electric lights, no modern conveniences. These amazing forces are electricity and magnetism, and they're about to rock your world. Electricity flows through wires powering our devices, while magnetism helps in countless ways, from simple fridge magnets to complex industrial machinery. We're going on a journey to uncover the secrets of these incredible forces. We'll delve into the science behind them, exploring how they work and why they're so essential to our daily lives. We'll discover how electricity makes things work, from tiny LEDs to giant machines. You'll learn about the flow of electrons, circuits, and how we harness this energy to power our world. Get ready to be amazed by the power of magnets, how they attract and repel, and how we use them every day. From holding notes on your fridge to enabling the motors in your appliances, magnets are truly fascinating. Fasten your seatbelts, science explorers, because we're diving into the exciting world of electricity and magnetism. This journey will be filled with fun experiments, mind-blowing facts, and a deeper understanding of the forces that power our lives. Get ready to be energized. By the end of this adventure, you'll see the world in a whole new light, appreciating the unseen forces that make everything possible. Electricity is like a river of tiny particles called electrons. These electrons are constantly moving, creating a flow that we harness to power our world. Just like water flows in a river, electrons flow through wires, bringing energy to our homes and devices. These electrons are so small you can't even see them with a microscope. They are incredibly tiny, much smaller than even the smallest atom. Scientists use special tools and techniques to study these particles and understand how they move and interact. They live inside atoms, the building blocks of everything around us. Atoms are made up of a nucleus surrounded by electrons, which orbit like planets around the sun. These electrons are essential for the structure and function of all matter. Think of it like this. Imagine a hose filled with tiny marbles. When you tilt the hose, the marbles start to move just like electrons move through a wire when an electric current is applied. The marbles are like electrons, and the hose is like a wire. The wire guides the electrons, just as the hose guides the marbles, directing their flow to where it is needed. When you turn on the water, the marbles start to flow through the hose. Similarly, when you apply a voltage to a wire, the electrons start to move, creating an electric current. That flow of marbles is like electricity. The continuous movement of electrons through a conductor is what we call an electric current, and it is the basis of all electrical systems. This flow of electrons is called an electric current. It is a fundamental concept in physics and engineering, and it is what allows us to harness electrical energy for various applications. It's what makes all our electrical devices work. Pretty cool, right? From lighting up our homes to powering our computers and phones, electric current is an essential part of modern life. Understanding how it works helps us appreciate the technology we use every day. Want to see electricity in action? It's all around us, powering our homes, gadgets, and even this simple experiment. Let's do a fun experiment that you can try at home or in the classroom. You'll need a few simple materials, a coin battery, an LED light, and some tape. These items are easy to find and inexpensive. First, take the coin battery and identify the positive and negative sides. The positive side is usually marked with a plus sign. Next, take your LED and look closely at the legs. You'll notice that one leg is slightly longer than the other. The longer leg is the positive side and the shorter leg is the negative side. This is important for the LED to work correctly. Now carefully tape the positive leg of the LED to the positive side of the battery. Make sure it's secure and making good contact. Next, tape the negative leg of the LED to the negative side of the battery. Again, ensure it's firmly attached. What happens? The LED lights up. This is because you've completed an electrical circuit. You just created a circuit, a closed loop that allows electrons to flow from the battery through the LED, making it light up. This is a basic principle of how electricity works. That's the power of electricity. It's fascinating how such a simple setup can demonstrate a fundamental concept that powers so much of our modern world. Section 4, Magnetism, the Attraction and Repulsion Mystery. Now let's talk about magnets. Magnets are objects that can attract certain metals, like iron and nickel. But have you ever noticed that magnets have two poles, a north pole and a south pole? Here's the cool part. Opposite poles attract each other, but like poles repel. So the north pole of a magnet will stick to the south pole of another magnet. But try to put two north poles together, and they'll push each other away. It's like magic, but it's actually science. Section 5, Magnetic Magic, a paperclip adventure. Let's try a quick experiment to see magnetism in action. You'll need a bar magnet and some paper clips. Hold the magnet close to a pile of paper clips. What happens? The paper clips jump up and stick to the magnet. Now here's the fun part. Try touching one paper clip to another. You might notice that the paper clip that's touching the magnet can also pick up another paper clip even though it's not a real magnet. That's because the magnet's force is strong enough to turn the paper clip into a temporary magnet. How cool is that?